Hello, this is Chiban Acharya. In this video, I will do the MyLab homework from section 2.2, organizing quantitative data and histogram. Um First question is about the definition. What is the class width? That's the question. What's the class width? So the class width is the difference between two consecutive lower class limit. Okay, that's the answer. Again, what is the consecutive means? Look at this uh, table here with the class 40 to 41, 40 to 43. For this uh, class, the class width gonna be 42 minus 40. That's the class width, which is 2 here. So class width is the difference between two consecutive lower class limit. So you can even do 44 minus 42. Again, you get 2, or 42 minus 40. That's also give you 2. That's the class width. Question number 2. Okay. Question number 2 has a frequency table and the classes, and here a class is given as the frequency of each classes is given, and the question number 2 asks you determine the number of classes in this frequency table below. So you count the class here: 1 class, 2 class, 3 class, 4 class, and 5 class. So number of classes here is 5. Again, this is the first class, 40 to 41. 48 to 49 is the very last class, which is going to be fifth class. That is what the number of classes here in this frequency table is: 5. Question number 3. Use the following frequency distribution to determine the class limit of the third class. If you look at the third class here, this is third class 27 to 33. So if you look at the limit of this third class, this 27 is going to be lower limit and 33 is going to be upper limit. So for the third class, lower limit going to be 27, upper limit going to be 33. That's the answer for this question, is number A. Okay. Number 4. The table below summarize the weight of the almond in gram in 1 pound bag. What is the class width? Again, we know the definition of class width. The class width is going to be difference of consecutive lower class limits. So if you think about this second class lower limit and first class lower limit, you subtract that. Let's see, 0.8185 minus 0.7585, or you subtract this and this, so you get 0.06. That's the class width. Okay. Question number 5. This is a definition question. What's the difference between bar graph and histogram? Remember that bar graph, we had this in last section 2.1, and histogram is here. What's the difference? Again, this is the definition question, and the answer for this question is B. The bar on the bar graph do not touches, while the bar graph and histogram do touch. That's the difference, one of the difference between bar graph and histogram. And bar graph is for qualitative data, but histogram is for quantitative numerical data. That's another difference, but we don't have option that, so we pick option B for this question. Okay. Question number 6. Here you have a data. We construct the frequency distribution for the data using 5 classes. Describe the shape of the distribution. So question number 6, again, first you construct the data and you describe the shape of the distribution. Remember that there is three shapes of the distribution. One is symmetric, the other one is the same as bell shape, and other one is skewed right, and other one is skewed left. So skewed right, other one is skewed left, and say skewed right. Okay, now we have to see by making frequency distribution table to find if the data is which of the distribution, symmetric, skewed right, or skewed left. Okay, to construct the frequency distribution, you got to find the first classes. Okay, and to find the classes, you look for the smallest data value. The smallest data value is going to be 98 here, over here, and the largest data value here is 145. So if you subtract 145 and 98 and you divide by number of classes we want is 5, so if you divide by 5 and you get 9.4, that's the class width about that. So class width is about 9.4. So I should say we can use 10 as a class width. So you got to find the starting point. So the 98 is smallest value. You can start from 95 if you like, or you can start from 90. So I should say start from 90, 90 to 99, the first class, 100 to 109, second class, 110 to 119, 120 to 129, 130 to 139. Oh, already have 5 classes here. Okay, but it looks like we need other one class because the largest value is 145. Again, to determine the if that data is skewed right, skewed left, or skew symmetric, it doesn't matter. You can do 5 classes or 6 classes. Is pretty much you get the same type of distribution. So luckily I got the 6 classes. I have to have a 6 classes here, but if I make a class with as a 11 and I start from 95, I might get 5 classes. Okay, but again, even if it's 5 classes, we can still make 6 classes to see what is the shape of the distribution. So it looks like I need to have a 6 classes here, 140 to 149. So I have a 6 classes here, 90 to 99. Notice that in this class everything less than 100 gonna be in the first class. Even 99.56 whatever gonna be in this first class. And second class, everything greater than 100 or equal to but less than 110 gonna be in the second class, and so on. So if you see how many data in the first class, 90 to 99, you can see here only have 98. So frequency of this class gonna be 1, and the frequency of second class, which is 100 to 109, let's see how many, everything less than 110 gonna be in the second class. So 108 here, 1 data, and 105 here is 2 data. So you have a 2 data value between these two numbers. The frequency of the second class is going to be 2. But notice that 110 going to be in the third class. Okay, everything less than 110 going to be in the second class. Similarly, you count frequency of each classes. The third class has a frequency 5. Let me do this for here. And fourth class has a frequency 6, and next class has a frequency 4, and finally 2. So total, of course you added, going to be 20. So that is called frequency distribution. Now to see what's the shape of the distribution, look at the pattern here. So majority of the data is between 120 to 129, and the frequency is going down as data is increasing, and in the same way frequency is less if the data is smaller value. So when you graph those data, they look like this. Let me graph that. Let me graph this for you. Let's see here, where does it go? I'm gonna graph here. So what it looks like is this. So we have a, let's put the frequency as 1, 2, 3, 4, 5, 6. Okay, so first class has a first class, the bar looks like this, has a frequency 1. Second class has a frequency 2, so I make like that. This is the 2 as a frequency. Third class has a frequency 5, 3, 4, 5 here. So third class has a frequency 5, and fourth class has a frequency 6. You go back here, and now see here how the bar is increasing, and this supposed to be decreasing on the same ratio. So next is going to be 4, so it's going to be 4 here, and next going to be 2 is going to be 2 here. So this pretty much, the shape of the distribution is pretty much bell shape, and so it's called symmetric. So in this question, the shape of the distribution is bell shape. Okay. All right. Question number 7. The question number 7 gives you the histogram here. The histogram is given, and you got to see what is the shape of the histogram here. I guess it is that here, and obviously it looks like here, as the value increasing, as a value, okay, as a value, the data value increases, the frequency going to be less and less. So it looks like the majority of the data value are in smaller, from let's say 0 to 12, but the bigger value 12, 15, 18, 21, if you go to the right, the bigger data value is going to be smaller in number. So this is called skewed right. So the graph looks like this. If you graph it, looks like this. So this distribution is skewed right. So in the skewed right distribution, smaller data value is more in number than bigger data value. Okay, that's correct. Let's see, next question, number 8. And this question tells you what's the shape of the distribution shown here, question number 8. Now obviously, unlike the previous question, you have a majority of the data values in the middle of the data set, and there is a smaller data value or same number as the larger data value. Look at the frequency, which is the height of the bar. So smaller data value here are same in number as a larger data value, and majority of data value is clustered around this middle value, middle of the data set. So this is called symmetric or bell shape, and graph looks like this. This is called symmetric bell shape. That's the answer. Question number 9. An experiment was conducted in which 2 6-sided dice are thrown 100 times. So if you have 6-sided 2 die that are thrown 100 times, then some of the pips showing on the dice were recorded. Notice that when you have let's say you have a die here, okay, 2 die, this tentatively, okay. So some of the pips, maybe one die is 1, other die could be 3. So some going to be by the time 4. So at most some going to be 12, because it could have 6 here. Another die could have 1, 2, 3, 4, 5, 6. So some could be at most 12. So then we roll the die 100 times and we record the sum. Okay, we record the sum. How many sum? Has to be 100 sum, because we threw the die 100 times and we recorded the sum. Maybe sometime you get the sum 12, sometime maybe you get 4, sometime you might get 2. Depends, right? Maybe you have both die could be 1 pink, then sum going to be 2, right? That's how you find the sum. See, maximum outcome going to be 12, the minimum going to be 2. So first part of the question is what was the most frequent outcome in the experiment? So here is the 7, which has most frequent because it has the highest bar on 7. So most frequent is sum 7. Okay, so that means if you roll the die, use 2 die, most frequent the sum 7 appears. Okay, that's the answer for the first question. Second question, what are the least frequent? Least frequent is 2. That's the least frequent because the 2 has a frequency just 1. How many times did we observe the sum of 6? See, 6 here, and the sum of 6 we observe here is 10. I should say sum 6 is going to be 10. Sorry, this 10 of 15, 16, 17. Okay, 17 times. Okay, again, this is the 15 here, this is 15 here, and 16, 17 is this, we observe sum of 6 17 times. So again, these are the sum unrolling the 2 die. So next question, how many more sum of 5 than we observe sum of 2? So sum of 5 and sum of 2. How many times we observe sum of 5? Sum of 5 we observe 10 times. We observe 10 times. And sum of 2 you observe 1 time. So we observe 9 times, 9 more. We observe sum of 5 than sum of 2. Determine the percentage of the times sum of 6 were observed. So how many times you observe sum of 6? 17 times. 17 out of 100, which gives you 17%. So how many percentage, or determine the percentage of the time a sum of 6 were observed? Answer is 17%. Describe the shape of the distribution. Obviously you see that this distribution is symmetric, bell shaped, and you can see as a graph like that. That's the symmetric bell shape, and this point here is 6, which is the and also median and also mode of this distribution. So the part F is describe the shape of the distribution. Choose the correct answer. The answer is, it is again bell shaped. Also bell shape is symmetric. Okay, all right. Question number 10. The following frequency histogram represent IQ score of a random sample of 7th grade students. IQ score are measured to the nearest whole number. The frequency of each class is labeled above each rectangle. You can see that frequency of this class 60 to 69. Notice that when you put that in the histogram, everything in the first class is every score less than 70 or more or equal than 60 belongs here. So pretty much first class going to be like that. First class is 60 to 69. In other words, every score which is less than 70 belongs here. If somebody has a score 69.5, also in the first class. The second class gonna be 70 to 79. So every score which is less than 80 or greater than equals to 70 gonna be in the second class. But if you have 80 as a score, which is gonna be third class. So that's how the class you can identify. So first question is how many students are sampled. To find the students, how many sample, you add all the frequency 1 plus 2 plus 12 and so on, and your total number of frequency, if you add carefully, this is 200 students are sampled. In other words, there is a score of 200 students. And determine the class width. Notice that class width is the difference of lower consecutive lower limit. So you do 70 minus 60, 70 minus 60, that's going to be class width. which is going to be 10. Okay, the 10 is the class width. That's the part B. Part C, identify the classes and their frequency. Again, first class is not 60 to 70. First class is 60 to 69. The second class is 70 to 79. So if you see that the first class is 60 to 69, what's the frequency of that class here? Frequency of first class is going to be 1. That's the frequency. And the class here, what's the frequency of second class? 70 to 79, which is going to be 2, and so on, so on. I'm not going to do that, but that's how you see. And the answer for this question here is, if you read that properly, that's the B as answer. Okay, you got to find the B as answer. They give you class 60-69, the first class, comma, frequency is 1. 70 to 79, second class, comma, frequency is 2, and so on. That's the answer. Which has the highest frequency? So if you look at this here, this class here is the highest frequency, which has 52 as a frequency. The class, how you name the class? 92, not 100, 92, 99. So that's the answer. So your answer is going to be the B, 90 to 99. So next question, which class has the lowest frequency? So I think this is the lowest frequency one. The first class, which is 60 to 69, which has the lowest frequency. So the answer is 60 to 69, which is the D. Next question, what percentage of the students had an IQ score at least 130? So at least 130 is here, 130 is here, at least 130 is more than 130. So how many students score more than 130? 7 students score more than 130, 4 students score more than 130, 2 students score more than 130. So what is that going to be? 7 plus 4 plus 2, which is going to be 13. So 13 students score more than 130 out of 200, and you divide 13 by 200, you get 6.5% of the students score more than 130. Or we can say that at least 130, 13, at least 6.5% of students has a score at least 130. So next part, the last one here, G, did any students have a IQ score of 164? Let's see, 164. There is no bar after 160. Looks like nobody scored 160 and higher. So answer is no, because there is no bar or frequency is greater than 160. That's the answer. Question number 11. The data, right, represent the top speed in kilometer per hour of all the players except goaltenders in a certain soccer league. Find the number of classes, part A. B, find the class limits of fourth class and the class width. Okay, there are 4 classes, 1, 2, 3, 4. Obviously the answer is 4 here. Part B, the lower class limit of the fourth class is going to be, this is first, second, third, fourth is 28, obviously. And the upper class limit for the fourth class is 27.9. 27.9. And the class width is, you subtract consecutive lower limit. So you subtract 16 minus 10. Or you can do 22 minus 16. Is the same thing. You get 6, 6. Doesn't matter which way you subtract. The class width is 6. That's the question number 11. Question number 12. The accompanying data represent the number of customers waiting for the table at 6 p.m. for 40 consecutive Saturdays at Bobak restaurant. Complete the part A through H. So the first question is the data going to be discrete or continuous? So let's see the data here. That's the data here. This is the number of customers, is the data, 10 customers, 13 customers, 6 customers. So so this data is obviously discrete, because this is the countable. You can count how many person are waiting. So the answer is the data is discrete. So part C is the answer for A. The data are discrete because there are finite or countable number of value. There is a finite value, obviously. So this first part A. Part B is construct the frequency distribution of the data. So you got to find how many customer between 1, 2, 3. So 1, 2, 3 means everything between 1 and 3. So that's is discrete. So let's see how many here. So let's see 3 here, 1, 3 here, 2, 3 here. So this class first has a frequency 2. Okay, because there is 2, 3 between 1 and 3. So that, in other words, there's 2 data between 1 and 3. Remember that this first class include 1 and also 3 because this is discrete data. So similarly, you count for second class 4 to 6. How many customers are between 4 to 6? And again, you look for any data value between 4 and 6 and see how many. I'm not going to do that, but I know I already counted for you. So it's going to be 3, and next going to be 13, next going to be 14, next going to be 8. So that's called frequency distribution of the data. And if you add all the frequency distribution, this is total going to be 40 data. So because we or somebody look for number of customer waiting table at 6 p.m. for 40 consecutive Saturday, so there's 40 data there. So relative frequency. So to find the relative frequency, you divided frequency by total number of frequency. So 2 divided by 40, 0.05. This is the frequency of class first. So answer is 0.05. So similar, to find the frequency of second class, you divide second class frequency 3 divided by total number of frequencies 40. This gives you 0.075. And so on. If you find the frequency of other class, it's going to be 0.325, 0.350 for the fourth class, and the fifth class of the frequency 0.200. I should say 0.2, or you can say 0.200. And if you add all this relative frequency, the total must be 1. Okay, this total must be 1. You don't have to do here, but just to see it, to check your answer, total must be 1. And also I can tell you this 0.5 as a relative frequency, you can put as a percentage, also 5%. Okay, this 0.75 for second class, 0.075 is also at 7.5%. So also you can see as a relative frequency as a percentage. Part D. What percentage of the Saturday had 4 or more customers waiting for the table at 6 p.m.? So, and if you look at this frequency distribution, 4 or more customers waiting for the Saturday at 6 p.m. Notice that in 3 Saturday, there are 4 to 6 customers waiting. In 13 Saturdays, there is 7 to 9 customers are waiting. Similarly, in 14 Saturdays, 10 to 12 customers are waiting. So more than 4 customers are waiting on how many Saturday? 3 plus 13 plus 14 plus 8. Pretty much you subtract 2, remaining going to be number of Saturday they are waiting at 6 p.m. So out of 40 Saturday, 38 Saturday, there are 4 or more customers waiting. Okay, only 2 Saturday between 1 and 3 are waiting, but other than that, more than 4 customers are waiting. So 38 out of 40 going to be 0.95. That's called proportion, by the way, if you want a name for that. Proportion. And this is same as 9.95%. Okay, that's the answer, 95%. So next question, part E. What percentage of the Saturday had 12 or fewer? If you look at the 12 or fewer, you're looking this number of customers, 12 or fewer, and 14 Saturdays, 12 or fewer, 13 Saturday, 12 or fewer, 3 Saturdays, 12 or fewer, obviously 4 to 6 customers. So basically subtract 8 to find 12 or fewer. They're going to be 40 minus 8 equals to 32. So 32 Saturday, 12 or fewer customers wait. Customers wait for in the table at 6 p.m. So 32 out of 40. If you divide 30 by 40, you get 0.8, which is same as 80%. So the question answer for this E is going to be 80%. Next question, construct the frequency histogram for the data. Again, the histogram you got to check and match with this frequency 1 to 3 2 frequency, 4 to 6 3 frequency, and so on. If you match, try to match that frequency table with this 4 option, the answer for this question is going to be B, because you see that 1 to 4, so 1 to 3 2 customers, and so on, right? That's the B. So relative frequency distribution is similar to frequency distribution. You just look for relative frequency on the y-axis here. So this is the D as answer, as relative frequency histogram. Okay, again, you need to match with the relative frequency distribution table with the relative frequency histogram. So looking at this this histogram, what do you conclude? Is the data going to be skewed right or left? That's the next question. Part H. So H is going to be, and if you look at carefully, this is going to be skewed to the left, because the reason for that is the left tail is longer than the right tail, because the graph, when you graph sketch it, it's going to looks like this. So there's a more Saturdays, you have higher number of customers are waiting on the table at 6 p.m. That's the question number 12. 13. The Internet Media Market Research Firm measured the amount of time individuals spend viewing specific web page. Okay, that's the time is given, how long they wait, how long they spend viewing specific web page. The data in the accompanying table represent the amount of time in seconds. So this time is obviously continuous data, obviously. So, and here's the time here. Somebody spent 19 seconds, somebody spent 86 seconds, somebody spent 27 seconds. These are the continuous data, because the time is the continuous data. So create the graphical summary and write the sentence that describes the data. So obviously this data is graphed in the histogram, and you guys need to match which one is correct histogram for this data. So here, this is the class is going to be 0 to 20 21 to 40, 41 to 60, 61 to 80. So this is the class with 20. So you got to see what's the frequency of first class, and you count number of data between the classes and see which one is correct. So in this question, the answer for this, so if you match carefully, this is the answer or correct graph for this 40 data. Okay, again, you have to look for what's the frequency of each classes, a count, and see which one match. So obviously this is the right histogram for the data, and then write a sentence that describes the data. Obviously this data is skewed right because there is a smaller value in the bigger in number. There is more smaller value on the data set. So this is called skewed right. This is the option for the second part. Describe the data is skewed right. Proceed. So use applet available below to complete part A through C, and I have applet here in this PDF file. So you guys just use the MyLab's applet and finish this question by yourself. Okay, it's not so difficult. Maybe there is instruction on the side how to use the applet, so you finish yourself. All right, thank you so much for listening.